A function URL is a dedicated HTTPS endpoint for your Lambda function. When enabling a function URL, Lambda automatically creates a unique URL for the function, which can be used to invoke the Lambda function. Function URLs are a great choice for a single function API endpoint which does not require the advanced capabilities of API gateway. In this video, let's learn how to create a Lambda function using dotnet and enable function URLs. We will see how to handle different requests and response from this Lambda function. We will also learn how to build an API endpoint and serve different types of HTTP requests from this same Lambda function using the function URL endpoint. Hello everyone, my name is Rahul and welcome back to this YouTube channel. If you're new here, I make videos on .NET, Azure, AWS and DevOps. This video is sponsored by AWS and is part of my .NET on AWS series. Without much delay, let's jump straight into learning all about function URLs. A function URL is a dedicated HTTPS endpoint, and when enabled, it looks of this format. So it has a URL ID and has the lambda-URL and the region on which the AWS Lambda function lives on with .on AWS at the end. Now we'll see how to create a function and then enable function URL from the AWS console. To create a new Lambda function, let's open up Visual Studio and select Create a New Project. Let's make sure to select a template. Since I have the AWS Toolkit installed, I get the different options to create Lambda projects. So let's scroll down and select the AWS Lambda project .NET Core C# and click Next. Let's give this project a name. So let's say User Service Function URL. Let's make sure it's in the correct folder and let's click Create. This prompts you to select a blueprint. This is nothing but the default starting code for this Lambda function. It gives you different options. In this case, let's select an empty function and click Finish. This creates an empty Lambda function with a single class for us to start with. Now, as you can see, the project is set up and here we have the function.cs and AWS Lambda tools.default.json file. Now, if you're completely new to building Lambda functions, I highly recommend checking out my video on how to get started with Lambda functions. I also have a Udemy course which will be linked in the description below. Now coming back, the function.cs is the class where we have the function endpoint. Now in this case, we have the function handler method, which is the entry point for our Lambda function. This currently takes in a string input. When calling a Lambda function via the function URL, the Lambda maps the request to an event object before passing it to your function. This event object follows the schema of the Amazon API Gateway Payload format version 2.0. Now, if you're new to API Gateway and want to learn how to build APIs in the gateway, you can check out my video linked here or in the description below. API gateways provide much more richer features and control over the API endpoint. Function URLs provide minimal functionality compared to them. However, let's keep moving and see how we can build the function URL. So for this case, the request payload needs to map exactly as the same as the API gateway payload. For this, let's come back and add a NuGet package to this project. Let's right-click on Dependencies and choose Manage NuGet Packages. Let's switch to the Browse tab and let's search for API Gateway Lambda. Now this filters out the amazon.lambda.api gateway events. Now this is the NuGet package that contains the request response for the API gateway payload. So let's make sure to select that and install that into the current project. Now that package is successfully installed. Let's collapse this and let's update the string input to use the API gateway request object. So let's search for API gateway and let's select the HTTP API v2 proxy request. Now this is the type that the Lambda will convert into when it receives a request at the function URL endpoint. So let's update this input to be request. Now let's update this input as well to be request And let's read the body property of the request and convert that into an uppercase and return it for this endpoint. Now this is simply to test the function URL endpoint. Now if you want to run this locally and make sure this is working fine, you can press F5 or click this mock Lambda test tool. I show you how this is set up in my Getting Started with AWS Lambda video. Now this automatically opens up a browser window, which is the mock Lambda test tool. Here you can see that it is automatically wired to this function handler as the endpoint. Now let's select an example request and let's scroll down and select the API Gateway v2 HTTP API. This automatically has the template for this request. So let's scroll down and update the body property. Now here, if you can see, this already has hello from Lambda. So let's click the execute function and see what is happening. Now you can see in the response, you can see that this is converted into uppercase. So we had sent this as a lowercase value, but this is automatically converted into uppercase just as the function was behaving. Now we know that this function is working fine. So let's close this and let's deploy this to the Lambda environment. To deploy this, I will right click on the Lambda function and choose Publish to AWS Lambda. Now this option is there again because I have installed the AWS toolkit. I have also set up the toolkit to connect to my AWS account. So you can see here the AWS credentials is having the profile.default. Now if you're new to how to set this up, I have a completely separate video on how to manage AWS credentials and how to set this up for your local development environment. You can check that here or in the descriptions below. Now let's give this function a name. So let's call this as user service and let's click next. Let's choose a role name. So let's select the AWS Lambda basic execution role, which provides permissions to write to CloudWatch logs. So let's select that and let's click upload. Now this is going to package our Lambda function and upload it into my AWS account. Now for a real world application, I would set up a build deploy pipeline so that the Lambda function gets automatically deployed anytime we make code changes. If you want to learn how to do that, you can check out my video on cloud formations, which will be linked here and in the descriptions below. Now our Lambda function is successfully deployed. So let's navigate to my AWS console and let's navigate to Lambda. Now inside here, you can see we have one Lambda function, which is the user service that we just deployed. Right now, this Lambda function does not have function URLs enabled. Now to enable function URLs, let's navigate to the configuration tab of the Lambda function and go to function URL. Inside here, we can select the create function URL. This prompts up an option to choose the authentication type for the function URL. This supports two different authentication types. One is the AWS IAM and the other is none, which means Lambda wouldn't perform any authentication on the request. This makes the URL endpoint public unless you implement your own authorization logic in the function. You can also enable CORS for your API and allow other origins to access this API endpoint. For now, let's leave this as unchecked and let's select none as the authentication type. In a follow-up video, I will show you how to use AWS IAM to authenticate the function URL. Now once you select none, it prompts that Lambda will automatically create the following resource-based policy and attach it to your function. This policy makes the function public to anyone with the function URL. So you need to be careful when you're using the none option that this endpoint will be publicly accessible without any authentication, unless you implement something within your Lambda function. So let's click Save to create this function URL. Now this automatically creates a new URL and you can see that inside this configuration here. So if you select this, it will invoke the Lambda function. Right now, you can see it returns an internal server error. This is because our Lambda function expects a body property on the request. Right now, this GET request is not passing any body as part of it. Let's open Postman, which is a utility that you can use to invoke web request. Now this is freely available to download and I'll put a link in the description below. So let's open up Postman. Let's create a new request. Let's select GET. Let's paste in the URL and let's also pass a body. So let's specify raw and then let's say hello and click send. Now in the response below, you can see this is converted to an uppercase. So this URL is currently mapped to our Lambda function that is deployed in my AWS account. So if I say hello from Lambda, this is going to again respond back with the new text. So you can see the function URL is right now working as expected. So if I was to come back into the Lambda console and navigate to the monitor tab, and let's open logs in CloudWatch. You can see the logs our Lambda function is currently writing. So if we navigate into this, you can see the different logs and the calls that has come here. Now you can see the first request returned an object reference not set to an instance of an object because the body was null. This is why it was returning a server error. Now that we have a simple endpoint working, let's see how we can update this code to take in a more complex request object. Most likely, when building API endpoints, we will be passing in JSON data. So let's come here and create a new class to represent our JSON data. So let's say public class user. Let's add two properties. So let's say we have a GUID property, which is the ID, and we also have a name property, which is string. So we add these two properties and let's convert the request.body into this user object. So let's say where user is equal to JSON serializer from the system.text.json, and let's use the deserialize function. Let's pass in the user type and let's specify the request.body. Now once we have the user object, let's use this to modify the response. So let's use string interpolation and let's say hello. Let's get the user's name and specify hello user with the ID and also specify the user ID. And let's close this string. And let's deploy like before. So let's right click and say publish to AWS Lambda. Since all the details are previously set up, let's simply click upload. This is going to upload the new version of our Lambda function to my AWS account. Now we have the Lambda successfully deployed. So let's navigate back to Postman and let's update this request body. So let's specify a ID. So let's specify the ID property and let's specify a random GUID. In Postman, to create a GUID, I can use double curly bracket and specify $GUID. This is going to automatically create a new GUID property. Let's also specify the name. So let's specify name and let's give Rahul. So let's make this as JSON. And you can see here, this double bracket is now colored differently because this is automatically converted into a random GUID by Postman. So let's make the request from here. And now you can see this will hit the Lambda function and return the new response. So we get hello Rahul with the ID a random GUID. Now if we make again, the GUID is going to be different. So let's make a request again and the GUID keeps changing. So now we are able to successfully send a JSON object to our function URL and have our Lambda function understand that and respond accordingly. Now this current endpoint does not care what kind of an HTTP request you are making. So right now I'm making a GET request, but I can also be making this as a POST and it will respond with the same information. Same for delete, put, patch or any of the HTTP verbs that's available for us. So let's see how we can update the Lambda function to handle the different HTTP verbs and behave accordingly. So let's come back to our Visual Studio. Let's close this and let's modify our function.cs. Now inside this function handler, you can use different properties of the proxy request to determine what HTTP verb is used. So let's use the request.requestContext.http.method property. This will be different based on the type of request that you're making. So let's switch based on this and let's handle different cases. Now to be safe, let's make sure we switch on the uppercase of this method so that we can simply handle one case inside our switch case. So let's say in case of a GET request, we can say handle GET request. So let's create a new method and let's pass in the request object itself. We can also do the same for post, and let's specify handle post request and pass in the request object itself. Now for anything else, for now, let's simply return a bad response. So let's use underscore to handle any other cases. Now when returning a string response, it is always going to take it as a 200 OK. So you can see here, the status is always coming back as 200 OK. Now if you want to modify this status codes, you can use a more complex return type. So similar to the API gateway HTTP API v2 proxy request, which is quite a long name, we can also use the API gateway proxy response as the response type. So similar to the v2 proxy request, we have the v2 proxy response. So this class allows us to return back with more advanced response properties. So let's use a new instance of that in cases of when it's not a get or a post. So let's return a new API gateway proxy response object. And you can see this supports different properties, which includes a body, cookies, headers, and also the property status code. So in this case, let's set the status code as HTTP status code dot bad request. Since this is a enum, we'll need to convert this as an integer because the status code is an integer property. So let's specify this as bad request. If we want, we can refactor this into a new method. So let's simply say this as bad request. Now we can return directly from this switch case. So let's comment out these two lines of code for now because we don't need that anymore. Now we need to implement these two handle methods. So let's do control dot and click generate method. Now this automatically generates the method for us, and it also has the response type as the proxy response. Let's do the same for the post request, and we have the two methods automatically generated for us. Now let's update the get method to handle a get request. Now normally in a get request, you would be passing some values using your query parameters instead of using the body property. Now since this is a user service, let's assume we are going to pass the user ID as a query parameter. So let's modify the handle get request. So let's specify the request dot query parameters property, and we can get the try get value. So we can specify the key, which in this case would be user ID, and let's specify out string, and let's say user ID string as the property name. Now if there is a value inside query string parameters, this is going to extract it as user ID string. Now since query parameters can be null, let's make sure to do question mark dot, which prompts us to also make this string as nullable. Now once we have the user ID string, let's try and make this as a GUID. So let's specify the GUID.tryPass method and extract the user ID from here. So let's specify the user ID string and specify out GUID user ID as the property. Now in this case, if this is not a valid user ID, so let's specify an if and specify the not condition. Let's return a bad request. Otherwise, we can find the user ID from our database, for example, and return the valid user information. Now, since we have specified the query string parameters can be nullable, we'll have to initialize the user ID string before this code. So let's specify string user ID string much before the query string parameters, and let's use that inside here. So let's also specify this as nullable in this case. So let's specify a question mark and declare this to be null at the starting point. Now this removes the error that we were getting here. Now once we have the valid GUID, we can use this to retrieve data from our database or from a file system or whatever data store we are using. For now, I will be simply creating a user from a hard-coded value. So let's specify new user and let's specify the user ID and the name. So let's specify ID is equal to user ID, and let's say the name is a hard-coded value for now. In this case, I will say name from database. Once we have the user, we can create a new response type and return it from our function. So let's say return new API gateway proxy response. And in this case, we want to also populate the body property. So in this case, we'll have to serialize it back into JSON. So let's use JSON serializer, serialize object, and let's pass the user object inside that. Now by default, the status is going to be 200, but you can also specify the HTTP status code explicitly. So you can say OK in this case. Now since this is an enum and the status code expects an int, let's convert this as an int again. Let's make sure to format this. So let's move this into the next line and also the status code in the next line. So now we are automatically returning a proxy response. Now our handle get is working as expected. Let's also handle the post request. In case of a post request, we would be getting the value from the body itself. So let's copy this line from before and let's use this inside here. So let's handle the case where the user is null. So say if user is equal to null, we can return a bad request again from our function. Now if the user is not null, we can add this to your database or any data store that you're using. So you can say add this to the data store as a comment. And let's return a API gateway response. So let's create a new instance of that response. Let's specify the status code. So we can say HTTP status code dot accepted if you want. And we can also specify the body. If you want, you can use the user.id as the property in this case. So we have accepted and created the user object. So since again this is an enum, let's convert this into int. And let's make sure this is also converted to string. Now we have both the handle get and the post implemented, and this is called accordingly. So let's remove the extra blank spaces. Let's make sure to build this. This is all building fine. So let's deploy this Lambda again. So let's say publish to AWS Lambda and click upload. This uploads the new Lambda function to our endpoint. Once deployed, let's come back to Postman. Let's make sure to choose the get option and let's pass in a user ID. So let's specify user ID equals. Now to create a random GUID, we can use the double brackets and specify GUID again. And let's click send. Now this time it automatically creates the new user object and returns the name from database as hard-coded. You can also see the status code here is 200 OK. Now if I miss to specify a GUID, so let's remove this and click send, this is going to return a 400 bad request because we did not supply a valid user ID inside the query parameter. Now even if you don't specify this whole user ID, we will get the same 400 bad request. Now this is because the query parameters would be null in that case and it would still return the bad request in our case, since we have handled for that. Now our get endpoint is working as expected. So now let's update this to a post endpoint and let's click send again. Now this is sending the body as the JSON as expected, because of which it returns the GUID that is added and also the status code is 202 accepted. So now you can see our Lambda function is acting as an API endpoint for the user resource. Now you can come back to your Lambda function and also handle for other HTTP verbs like delete, put or patch, etc. and have the implementation accordingly. Now if you are persisting this data to a database, you can very well make this as an API endpoint for your real-world application. I will leave the implementation of delete and the other verbs for you. I hope this helps you to understand about function URLs and how to use them in Lambda functions. We learned how to create a Lambda function and how to enable a function URL on that. We also saw how to use complex types and pass in JSON data to our Lambda function. We also saw how to use the response object to create different responses based on your API needs. Right now, our function URL is not protected, which means anyone with this URL can invoke our Lambda function. However, when building applications, you want to make sure that these are secure. So for this, in the follow-up video, I will show you how to enable auth IAM for your function URLs and protect your function URLs using the AWS IAM authentication model. Make sure you hit the subscribe button to be notified when that video comes out. If you like this video, please make sure to hit the like button. And if you have any questions, don't forget to drop them in the comment section below. Thank you and see you soon.